Hello, everyone. As you can see, I've changed the way the beginning of these casts are going to go from now on. I just kind of took out the music. I didn't feel that it necessarily fit, and I've been wanting to add some editor notes kind of at the beginning of these because each person has been so different that I think they each deserve their own better introduction after I've already sat down, talked to them, and got a better feel for exactly who they are. I walked into this one not really knowing exactly what I was getting myself into. I typically don't write down questions for anybody who didn't know that. I just kind of let a conversation happen. Me and my guest, we happen to have a very similar love of a specific subject, and it pretty much dominated the entire cast. But that's fine. I found it to be one of the more interesting ones that I've done to date as far as this goes. It really held my attention and gave me something great to listen to. I've actually, going through the editing process and everything else, I've gone over it a few times, and I've heard it a few times, and it still is extremely interesting to me. I think you'll like it as well. I'm quite sure that quite a few of you may actually even learn something from this one. Also, it's kind of funny. Sometimes you'll have guests on and you just naturally expect that they're going to come on and they're just going to talk. And sometimes you get guests and you go, I'm not sure if he's going to be as talkative. And they're really hit and miss. A lot of times you're just wrong. I've had guests in the past already who I thought that I'd get on there, we'd have this great conversation, and we'd be done in an hour, lickety-split, no problem, and they take, an hour and a half or what have you, and 2 hours sometimes, in some cases 6 hours. But these things happen because you do want a fluid, natural conversation to come out. This did not have that problem. I wasn't sure exactly whether he was going to be talkative or not. I know that he doesn't mind talking, but in his other roles on other shows, he's kind of the side guy, so he doesn't dominate conversation very much. I got him on here. I just pointed him in a direction, and he just went. This is probably the cast that to date I spoke the least in. I hope you guys enjoy it. I know I sure enjoyed recording it. Hello, everyone, and welcome to the Imps Prison. I'm the warden of this institution, Angelo. And from my watchtower, I keep order, but once in a while, an inmate just got to be brought up to have a little sit-down. And today's inmate is the mad scientist of this asylum. He and his robot ninja kitten space monkeys stare down on us, passing judgment. Don't let the bow tie fool you, people. This guy's dangerous. My guest today is Cluze.
Well, hello, Warden. The funniest thing about all of that is that in my professional life, my non-magic life, the project that I work on is actually called Skynet.
Oh, okay.
That's no joke. We really actually call it Skynet. So, but yeah,
so
I'm sure.
Building the Terminator?
Sort of. We haven't armed anything yet. Depends on how the funding comes out, but we'll see. But yes, I'm Cluze. So hello out there to all you folks in, let's call it listener land.
Sure. That's what you want to call it. We'll call it listener land. The interwebs.
Yes, the interwebs. We're up from the internets. Yes. So I'm Cluze. Yeah. So lots of folks may know me from places like Monday Night Magic, where I'm a regular host, Card Advantage, where I'm also a regular host, or from judging. I get around, make the rounds. I am a level 2 judge for Magic, so I'm often wearing the blacks when the big tournaments happen. Yeah, I've been to several GPs, FCG events, those sort of things. I've not been to a pro tour yet, but that is on my to-do list of trying to make it to a pro tour. And of course, seeing me in person, you can find me most weeks over at Atomic Empire in Durham, North Carolina, which is a great shop, and you should check it out if you're ever in the area. I know I love it to death. I'm not there now because, it's the holidays, visiting family, and all that jazz. But, in my professional life, I do something a little bit different. I'm actually an astrophysicist by trade.
That's absolutely awesome.
What's really great about that is it's really fun at parties because it sounds like a joke. It sounds like the punchline to a joke. It's like, oh, what do you do? Oh, I'm an astrophysicist.
Okay.
I don't get it. So, but I get that a lot. It is a kind of a fun profession. I have a deep, deep love of science and astronomy, not astrology. I want to put a kibosh on that right away because astrology is not actually a science.
Darn. I was going to ask you, what was going to happen today because I'm a Gemini.
Yeah. Well, as best I can figure, the sun will set, and tomorrow it will rise, and that's pretty much all I can tell you, astrologically speaking.
Well, see, astrologically speaking, though, wouldn't that? Well, I guess astrologically speaking, it would be correct. But as far as astronomy speaking, the sun doesn't actually set.
Oh, goodness, no. The sun does not care at all. The Earth spins. Can you feel it? Can you feel it out there, everyone? Close your eyes.
If you're stuck to the ground, you can feel it.
Spinning. It's insane. But no, yeah, so, yeah, astrology. If I can just digress for a moment. By the way, I apologize in advance to anyone who's never listened to me on a podcast. There will be digressions. It's the way it works. If I could digress for just a moment. Astrology is one of those things. It does fascinate me that anyone believes any of it, to be honest with you. So it's been around for a long, long time. And for what most people don't quite know is they know what their sign is, but they don't really know why that's their sign. So if you look back historically, the idea is if you look up in the sky right now, whoever's listening to this, I don't know where you are or what time of day it is, but let's say it's daytime. If you look up in the sky right now, the sun is currently, quote unquote, in a constellation. That is to say, if I could dim the sun, if I wielded supreme phenomenal power and could just stick a rheostat on the sun and just dim it, you would see it. There are stars behind the sun. The stars are there all the time. It's just the sun is so bright you don't see them. So the sun is currently in a constellation. And the idea of your birth sign is, in theory, that's where the sun was when you were born. That's the constellation it was in. Now, the problem with that is astrology has been with us for a long, long time. And the Earth goes through a bunch of different motions. So it rotates on its axis. It also orbits the sun, but it also precesses. If you think of it like a spinning top, the tilt of the Earth, because you know the Earth is tilted. It's what causes the seasons, by the way, for those who don't know that. A lot of people don't know that. Anyway, so the tilt of the Earth, it spins like a top. So where the North Pole is pointed changes over time. So right now, the North Pole points pretty close to this thing called the North Star. We call it that because it's right by the North Pole. But that's not always true. So the Earth is slowly tracing out this little circle on the sky. So right now, we're pointed at the North Star, and I think its period of precession is something like 26,000 years. So if we wait 26,000 years, the pole will slowly point not at the North Star, and then it'll come back around to the North Star. So we live at kind of a unique time in the history of Earth that we have a North Star. But that's a digression on top of a digression. Let's come back to astrology.
Yeah, really.
Because of the precession, where the sun is when you were born is not the same place as where the sun would be if you were born thousands of years ago at the same time of year. So your sign, quote unquote, you're probably off by about a sign. And I can't remember if it's forwards or backwards. I don't pay any attention to astrology most of the time. But your birth sign
to know
is
a lot more than you should for somebody who doesn't pay much attention to it.
Yeah, well, look, when you introduce yourself as an astronomer, they immediately start asking you at the cocktail party about astrology. And so you've got to be ready. You need to be prepared to let them know that, yeah, everything you know is wrong. And so let's just get that out of the way. Let's just put it aside. So anyway, there's a digression on astrology for you. It's also utter nonsense. The whole concept of astrology is that somehow where the sun is, and more importantly, where the planets are, which constellations the planets are in, somehow changes or influences your life somehow. And I've seen hand-wavy arguments about, gravity doing something. But here's the thing. Okay, so gravity is amazing in that gravity, of all the fundamental forces of nature, other than the force of habit, which is the most powerful force of nature, gravity is one of those forces that it extends over infinite distance technically. It just gets very, very small the further away you get. So right now, the Milky Way galaxy that we're in is actually careening towards another giant galaxy called Andromeda. And if you go out in a really dark location, you can actually see Andromeda with the naked eye. It's a faint fuzzy patch. But we are falling towards Andromeda right now. But the crazy thing is, because of how gravity works, being symmetric, we, as human beings, you, Angelo, you are pulling on the constellation of Andromeda right now. You're pulling on the galaxy of Andromeda right now.
Well, I'm that strong,
Yeah, that's right.
Come here, you.
But the thing is, that actual force is tiny. So if you actually care about where the planets are when you were born, that's just all nonsense. You could put a glass of water near you on a desk, and it's pulling harder on you gravitationally than Saturn. So just ignore all of that. Now, the one thing.
This explains why I keep grabbing for the Mountain Dew.
Let's just delve into some more pseudoscience for a second. one argument I've heard about how astrological signs and personality types from astrological signs, how it may work, is that what actually matters is how much sunlight your mother had while she was pregnant with you, because the amount of sunlight you get influences the amount of vitamin D your body can manufacture. So there's a little bit of an effect there that maybe we can argue about. But I'm from the north in the U.S. originally, and I work down in North Carolina, but I'm from up Michigan and northern Indiana sort of way. So yeah, we don't get much sunlight anyway.
No,
so,
you don't go outside.
Yeah.
There's 3 months out of the year. You just don't leave.
Yeah, pretty much. I'm inside right now because it's cold out there.
Yes, it is.
Don't get me wrong. I love the cold. There's another thing that I'll talk about briefly. So I may work in North Carolina, but I hate the weather there. I absolutely despise the weather in the South. It is way too hot most of the time.
I have to agree with you. I actually lived down there for a while, and it wasn't really the heat that got me because we actually get fairly hot here in Pittsburgh, but the humidity, just the swamp stick, as I like to call it, it's just oppressive.
It is insufferable. Absolutely terrible. I always joke that I would rather that I actually have 4 seasons where I live, and that instead North Carolina, they do have 4 seasons, and the 4 seasons that you get are fall, spring, summer, and oh God, it's August. And
yes, oh God, it's August.
I much prefer to have winter in there because winter's way, way better.
Well, winter keeps the size of cockroaches down too.
Yeah,
I noticed that.
It's there's a very old episode of The Simpsons that I always like to joke about, and they accidentally introduce I used to be a big Simpsons fan. I haven't really watched in years, but they accidentally introduced some sort of an invasive species to Springfield, and so I think it might have been some sort of a lizard, and so they introduced a bird to eat the lizard, and then some sort of cat to eat the bird, and there's this chain of animals that they introduced to take out this invasive species, and it ended with, I believe, gorillas. And the idea was it's okay because in the winter the gorillas will die. And so, winter takes care of a lot of things, quite frankly. But, then we could turn to climate change if you really want to open that can of worms.
Oh boy. Well, folks, if you haven't figured this one out, this is going to be a very sciencey episode of the Imps Prison because I'm a bit of a science nerd, and Cluze, obviously, he's been talking for 10 minutes nonstop about astrology. So,
so I can even talk scientifically about crap. So, but no, let's take a step back to where we began, which was Skynet. Okay. Let's talk about what I actually do for a living when I'm not doing magical stuff. So, I work for UNC Chapel Hill, for those who don't know, which is why I'm often in Durham, North Carolina, which is just next door to Chapel Hill.
Isn't that where Duke's at?
Duke is in Durham. Here's the thing.
See, you're kind of like being a trader just going into that town.
Right, but here's the thing. I actually don't care about UNC or Duke athletics in any way. It's not that I don't like them. It's that I just don't care. So it's fine. Other people can enjoy them. I'm not trying to disparage any of that. That's fine. Go ahead and enjoy them. It's just not my thing, okay? If I'm gonna follow sports, particular college sports, it'll be Notre Dame because that's where I grew up. That's where I went to undergraduate. So I do have a soft spot in my heart for Notre Dame. And
you know what? I actually have something to tie into that.
Yeah.
And it ties into what you do for a living and everything.
Okay.
A good friend of mine who I grew up with, his name is Justin Krepp. He is a professor of astrophysics at Notre Dame. He's actually just recently been credited with being the guy who discovered a planet that could sustain human life outside of our solar system.
Oh, fantastic. Hey, if, let him know if there are any openings in the physics department and they're looking for someone, let me know.
Yeah.
I'm actually looking for a job back in the north. But anyway, that's a whole nother topic. We'll get to that in a few minutes, I'm sure. But anyway, back to what I do. So down in North Carolina, that's where I work. And my research group, I don't run it, I'm just a part of it, but the research group that I work with, we run a global network of robotic telescopes called Skynet. And we named it that way on purpose. We knew what we were getting into. It was pretty funny, but it does raise some eyebrows occasionally at those cocktail parties. But anyway, we are theoretically in the gamma ray burst business. So gamma ray bursts are the death of a supermassive star. So if you're familiar with the concept of a supernova when a star dies.
Yeah, there's been a couple of those actually that have been recently discovered through telescopes where people are actually seeing them in the distant space.
Yeah.
I just saw one a couple weeks ago, actually.
Yeah, so gamma ray bursts, they go off all the time. There's one on average somewhere in the observable universe every couple of days, but we don't always detect it. We don't have a telescope ready. But here's the thing. Gamma ray bursts, they're kind of like uninvited guests. You never know when they're going to show up.
And then they make hulks.
Yeah, that's right. So we can't predict where they'll be. We can't predict when they'll be, but when one goes off, we want to observe it as quickly as possible because they evolve very rapidly. They change very rapidly. And so we want to get as much data as quickly as possible. And so human beings running a telescope are too slow, so we need robotic telescopes so they can just automatically take data for us. And because we don't know when one will go off, just having one telescope is no good because, your chances of it being nighttime and the weather being good at just one location, not great. So what you want is a distributed global network of telescopes. So, we're the opposite of the British Empire. We want the sun to never rise on Skynet rather than the sun to never set on the British Empire, but that's a history joke. So we have telescopes kind of all over the world, several throughout the U.S. We've got a big cluster of them down in Chile, in South America. We just built some over in Australia. And so the idea is when one goes off, our robotic telescopes will observe it, and, we get the data very, very quickly. Now, the thing is, these things, like I said, they happen on average, about every couple of days. But to actually have one that's observable, it's more like once every 2 weeks or so that we'll get a good one. So the question is, what do the telescopes do the rest of the time? And that's why I say that we're theoretically in the gamma ray burst business. I mean, it's kind of our bread and butter and what we do, but our telescopes are used for much, much more than that. So we've got a whole bunch of collaborators at different universities and institutions all over the globe who use our telescopes for all kinds of different stuff, supernova searches, asteroid studies, variable stars, you name it, they can do it with our telescopes. We've actually had a couple of exoplanets discovered with some of our telescopes. So,
explain what that is, because I'm sure a lot of people don't know what an exoplanet is.
Right. So yeah, here's another good one. Exoplanets are kind of the hot, sexy topic right now in astronomy, and so you'll see it a lot in the news. An exoplanet is just a planet orbiting a star that isn't the sun, and so it's only in the past decade or so that we've really gotten good at trying to discover these things, because it's really a tricky problem, right? The nearest star to Earth is the sun. There's a joke for you. The nearest star other than the sun to Earth is Proxima Centauri, or there are several stars that actually orbit one another in the whole Proxima Centauri system. But it's about 4 light years away or so, give or take.
Okay.
And so seeing a planet around a star that close is tricky. But if you make the star even further away, then it gets harder and harder and harder. So there are a variety of techniques you can use to find exoplanets. But it's gotten really sexy in the past few years because we've gotten much, much better at it. There's something like somewhere around 1,000 confirmed exoplanets have been discovered thus far. There's something like 2,000 or 3,000 or so that we think are exoplanets, but we haven't quite verified it yet. We have like 1 or 2 observations that are suggested. But these days, the big new hotness is to find habitable planets. So so now here's another digression into exoplanets. You can think about all of the planets orbiting a star. In our own solar system, we've got 8. Pluto's not a planet. If you want to talk about that, we totally can. I have strong feelings about it. It's totally...
Are you one of the ones who killed Pluto?
Okay, here's the thing. Let's stop right there. Nobody killed Pluto. Pluto doesn't care what you call it.
No,
it's still there doing its Pluto thing. The really sad part is Pluto
use the word planet, though, when they describe Pluto. It's just they put a word in front of the word planet now.
It is a dwarf planet.
Right.
Hey, look, we're on this topic. We're going to talk about Pluto for a second, because here's one I feel very strongly about. So, Pluto was discovered in the late 1920s, early 1930s. It hasn't even completed a single orbit since it was discovered. So, we discovered Pluto, figured out that it was something special, called it a planet, let it be a planet for a while, demoted it from planethood, although I actually will argue it in just a moment that it is a promotion, and it still hasn't completed one orbit. It's just kind of funny that the way that is. But here's the thing. Pluto really doesn't care what we call it. So if you think about when Pluto was a planet, when we had the 9 planets, a lot of people think, 9 is some sort of this sacrosanct number. It's written in stone. Look, astronomy actually has a very long tradition of promoting things to planethood before realizing that was a terrible mistake and taking it away. At one point, we were up to something like 48 planets in our solar system.
Oh, geez.
Now, a bunch of those things were just garbage that was sitting in the asteroid belt, and we realized, oh, hey, wait a minute, those things, they're not really planets, let's call them something else, and we brought it back down. So, for the vast majority of human history, we think of 9 as being a special number just because it's been around for us, but written human history only goes back to like 4000 BC or so. And so in all of that time, we had the following planets. We had Mercury, Venus, Earth wasn't necessarily in that category yet, but let's go ahead and stick it in there. So Mercury, Venus, Earth, Mars, Jupiter, Saturn. That's all we had. We had 6 planets for the vast majority of human history. And it wasn't until something like the 1700s when we found Uranus, and then the 1800s when we found Neptune, and then we had Pluto in the early 1900s. So we added those just recently. It was just a short time ago. And during that time period, when we were discovering those others, we ratcheted it up. We had like 9 and then 11 and then like 48, and then we dropped back down to 7 or 8 and then got 8 and then got 9, and then we dropped it back down to 8. It's perfectly fine. Perfectly natural. But if you think about when Pluto was a planet, so it was the crappiest planet, right? It was the one that did all the things it wasn't supposed to. It was a rocky planet out where rocky planets didn't belong. It had a tilted orbit. It wasn't really in the plane of the rest of the solar system. It was tilted at a harsh angle. It crossed Neptune's orbit. When we discovered its first moon, because we're up to like 5 moons that we have for Pluto.
Really? That little planet has 5 moons.
That's right. That little tiny planet has like 5 little tiny things orbiting it. But here's the funny thing. If you look at Pluto and Charon, its first moon, Charon doesn't orbit Pluto. Pluto and Charon orbit a point in between the two of them. That's how big that moon is relative to that planet. So it's there are a lot of things about Pluto that were crappy. And so we took it out of planethood, and instead of being the crappiest planet, it is now the second largest dwarf planet. That's a promotion. That's a great thing.
So, okay, if you look at it that way, what you're saying is it just became Reno?
It's the Reno of the solar system, yes.
Okay, fair enough. All right. Wow, that was a lot to chew on there.
Yeah, sorry.
No, it's fine. It's fine. I'm trying to listen to you in case there's something that I didn't already know. My big question is, why couldn't someone come up with a better name for Uranus? Because it doesn't matter. Either it sounds like you're talking about piss, or you say it the other way, which is Uranus. And I mean, well, hey.
Yeah, that is an unfortunate quirk of history. There's a great YouTube video by, God, what is his name? Is it C.P. Gray? There's a guy who does YouTube videos about interesting topics like this, and he's got one just specifically on this one. When we name planets, we have sort of naming conventions that we've been using, and they're not always great, but Uranus or Uranus or Uranus, or Uranus, actually, I've heard it pronounced. This was a god of the sky. There was an ancient god. So it was perfectly fitting conceptually that this guy ought to be there. But, I feel that science as a discipline could benefit from the same thing a lot of marketing departments could benefit from. And it's like the 5-year-old test. So find like a 5-year-old kid. Tell him the thing you want to name something, and see what he says.
He'll say Axe Cop. Have you ever seen that?
Oh yeah. Well, I'm not saying let him name it. I'm just saying when you come up with some sort of a name or a marketing slogan, find some elementary school kids, run it by them, and if within like 3 minutes they can start to say embarrassing, funny things about it, maybe rethink what you've done.
Good plan.
So yeah, it's unfortunate, but I'd like to rename it. But what would we call it? I'm sure they'd come up with something else equally.
You know what you should call it? Angelo.
Angelo, that's right. Yeah.
I don't have a big head or nothing.
Jupiter, Saturn, Angelo, Neptune, yeah.
Yeah, it works. It works to me. It fits. Hey, what can you say? All right, so as many people know, like the Science Channel, right? A lot of America gets their science from the Science Channel, and little known fact that a lot of people don't quite realize is a lot of the crap they put on there is not true.
Yeah, well, okay, so the Science Channel is not bad. It's not perfect by any stretch of the imagination, but it's not bad. The quote-unquote history channel no longer shows history, and the quote-unquote Discovery Channel doesn't really do science much anymore either. And those two things things grieve me, quite frankly.
Well. I watch H2 a lot more than I watch history because it's more the way history used to be.
Yes.
But like the Science Channel, it was just a couple months ago I was watching this, and this will fit right into our conversation. And they were talking, they had some scientist on there, and he was talking about our solar system being a dual sun solar system. But it's a red dwarf, and we haven't discovered it yet. And a lot of what he was saying was the pull for Pluto, it being on a different axis, was his major reasoning for it. And if you look at the Kuiper belt, he says that you can actually see the asteroids. Kuiper belt is our second asteroid belt, for those who don't know. You can actually see asteroids going around something out there. And he believes it to be a brown dwarf. How true is this?
I'm going to call it, for the most part, utter crap.
Okay.
Now, I'm not saying it's complete crap, because there is quite a bit about the outer edge of the solar system that we don't fully know, because a lot of the stuff out there is small, and there's not much light hitting it, so not much light reflects off of it, so it's hard to see, but there's junk out there. So you're absolutely right. The Kuiper belt, just think of it as the asteroid belt out beyond Pluto. In fact, Pluto is likely a Kuiper belt object, and the vast majority of the other dwarf planets that have been found, things like Eris, not Eros, that's an asteroid in the asteroid belt, but Eris, the one that got Pluto demoted, the one that's bigger than Pluto, those are all Kuiper belt objects. Now, the thing about the Kuiper belt is, if you think about our solar system, it's mostly in a plane. It's mostly in this flat plane, except for Pluto, who's tilted. But the Kuiper belt out there, it's a little thicker than that plane. So Pluto comes in from the Kuiper belt and goes back out, essentially, into the Kuiper belt. So it's got some thickness. Think of it as a donut around our solar system. And there's a lot of crap out there. And there could be crap out there that's somehow orbiting some other object. I'm a little skeptical of that. But, the idea that there is a quote-unquote brown dwarf out there. Well, let's talk about what a brown dwarf is, first of all. So a brown dwarf is, we call it a star, but it's really a failed star. It's something that you can usually think of it as bigger than a planet, but not as big as a star. It's like it's a big collection of gas and junk that never got big enough to do fusion. Because that's what it takes to be a star. Doing fusion is what it takes.
So it's a bigger version of Jupiter.
Exactly, and that's the thing. You can almost argue that Jupiter is a brown dwarf. It's a little small for a brown dwarf, and most people wouldn't classify it that way. If you just found Jupiter just floating out in the cosmos, it would probably be classified as a rogue planet rather than as a brown dwarf. And what I mean by
another subject, rogue planets.
Yeah, I was gonna say what I mean by rogue planet is a planet without a star. It's not orbiting anything. It's just careening through the cosmos. And these things can happen. We can talk all about that if you really want to. But anyway, the idea that there is something Jupiter massed, or if you're going to call it a brown dwarf, bigger than Jupiter mass, out in the Kuiper belt, and we haven't seen it, is pretty much ludicrous.
Fair.
It would take, Jupiter is huge. It's enormous. I mean, that's why it's so bright when you see it at night. But, the idea that we have something out there, I'm just not buying it.
Neither was I. I was sitting there watching it going, this is utter crap. I can't believe they're putting this on the Science Channel. But I guess, everyone has to have a hypothesis before it can be disproved.
Well, there are people who believe that there is something massive out there. And one of the reasons for that is junk falls in from the Kuiper belt with startling, I'm not going to call it regularity because it's not like it's on a schedule, but a lot more commonly than you would think. Comets, for instance. Comets are mostly Kuiper belt objects. Some of them are Oort cloud objects, which is out beyond the Kuiper belt, but let's not go there quite yet. But if you have, for instance, if you have a nice collection of junk, you'd need to perturb its orbit somehow, disturb it somehow to get it to fall in towards the sun. And so one of the ideas is that there is this big, massive object. Sometimes it's dubbed Nemesis. Out in the Kuiper belt or out beyond the Kuiper belt that's disturbing these things gravitationally and flinging them in. One of the reasons it's called Nemesis is the idea is, well, it's going to destroy all life on Earth by throwing rocks in towards us, which, by the way, is a valid concern. That's actually something to be worried about. Yes,
that's actually what they was referring to the dwarf as. They was calling it Nemesis. That they was saying that it was a dwarf.
I get this one. But, the thing that people need to be aware of is that space wants you dead.
Yes.
It's cold, it's unfeeling, it sees no reason that it shouldn't pummel us with rocks or have our sun explode. One of the downsides to being an astronomer is you start to take a big picture view of things.
We're all gonna die.
Yes, we are all going to die, period. I mean, yes, a lot of people ignore their own mortality, but that's like 100 years or so. That's a pittance. That's nothing to an astronomer. That's the blink of an eye to an astronomer.
If that.
I take a long view. I know for a fact that in about 4.5 billion years, our sun will die. When it does, we can't live here, period. In fact, when it starts to reach the end of its life, the sun is going to fluff up like a big ball of cotton candy, if you will. And the surface of the sun will be roughly where the moon is. Depending on whose models you believe, it'll be somewhere between Venus and Mars.
So get your suntan lotion.
And the thing is, that gives us a time limit, right? We only have 4 billion years to get off the planet. That sounds like a lot of time, but here's the thing. Before that, as the sun fluffs up, the amount of energy we get from the sun will actually increase because it's bigger in the sky, essentially. And so the surface temperature of Earth will be roughly that of molten iron in about 2 billion years. And at that point, all of the oceans will evaporate because the surface of the Earth is too hot, and then we all die. So I only give us about 2 billion years at the best.
Okay, so what happens first? Does our sun explode, or do we collide with Andromeda?
Our sun won't quite explode per se, so we'll come back to that in a second.
Okay.
The Milky Way galaxy is going to collide with Andromeda in give or take 4 billion years. The sun is going to exhaust all of its hydrogen and die in give or take 4 billion years. So those two things are going to happen right about the same time, astronomically.
All kinds of chaos will be going on.
Oh yeah, absolutely. In fact, if the Earth survived, it would probably become a rogue planet around then, because when we quote-unquote collide with Andromeda, galaxies are huge empty spaces. And when they collide, most stars won't run into other stars, but they will get close enough to other stars that all the things orbiting them will get perturbed gravitationally and get flung off. And so we wouldn't have a sun to orbit, even though the sun won't be there because it's going to die. But anyway, when the sun does die, as it fluffs up, it's going to blow off its outer layers, and it's essentially going to die as a white dwarf. So
okay, it's not going to go full supernova.
Yeah, it's not big enough to go supernova.
I thought they continued to grow. It was kind of a misconception that maybe I had, where I thought they continued to grow until they supernova.
No, definitely not. Yeah. So unless we can pump a bunch of fuel into it, and I do mean a bunch of fuel into it, yeah, it's not going to blow up. It's too small.
Darn. So let's just start firing nukes at it. Let's get this thing going, right? Whole bunch of nukes too. Okay, so the Andromeda collision. Mm-hmm. Is this going to be a direct collision where our supermassive black hole collides with its supermassive black hole? And what happens if that happens?
Right. Okay. So, the two black holes probably won't collide, at least not initially. They'd have to hit head on for that to happen.
Right.
What's more likely to happen is that the Milky Way will fall through Andromeda, kind of swing around the backside and fall through Andromeda again until we've kind of fully merged. Eventually, we should end up with a scenario where one supermassive black hole is orbiting the other supermassive black hole, and then something weird happens. So, as they're orbiting, they're going to slowly lose energy, which doesn't really seem to make much sense because they're just in space. It's not like there's friction and they're rubbing against something, except what they're actually doing is they're warping the fabric of space-time. And so they give off these things called gravity waves that are essentially ripples in space-time. And slowly, the two black holes, as they orbit one another, they'll get closer and closer and closer together. And when they do, they merge. Now, the merging of two black holes isn't necessarily all that spectacular. It's not like there's a big explosion or something. You just make a bigger black hole. But you do give off a whole bunch of gravity waves when you do that. And
so there's no quasar when these two collide or what have you.
Okay, well, let's talk about quasars. Because I actually studied quasars in graduate school. My dissertation actually dealt with an active galactic nuclei, NGC 5548, for anyone who wants to look it up at home. It was a terrible dissertation, and I hated the project altogether. But still, it was a thing that I studied in graduate school. So, if you want a quasar, what is a quasar anyway? So, here we'll take a step back. We believe that nearly every galaxy has at its heart a supermassive black hole. What do I mean by supermassive? Well, we know the sun is big, right? But imagine having like thousands or millions of times the mass of the sun compressed down into a point. That's a supermassive black hole, like millions of solar masses worth of material in a black hole. We think all galaxies have one at their center. Now, the reason I bring it up is that quasars are a type of active galactic nuclei, which if you break that sentence down, nuclei we just mean the center of, so the center of galaxies that are very, very active. How can you have an active center of a galaxy? Well, take a black hole and dump gas into it, and ironically, they will make some of the brightest objects in the universe. But wait a minute, Cluze, I hear you scream at your iPod. By the way, the guy on the bus is looking at you really weird now because they don't know who Cluze is or why you're screaming. So, a black hole is by definition dark. It doesn't give off any light. But if you have gas that's falling into that black hole, that gas gives off light. And through some arguments of angular momentum that I won't get into, if you dump gas into a black hole, it'll actually flatten out into a disk around the black hole as it spirals into its doom. But that disk of gas, if you think back to
layman's terms, think a ship in a whirlpool from a cartoon you watched as a kid.
Yes, that's a very good analogy. Except now do it in 3 dimensions. So, but no, it is a flat disk. If you think back to your days, your early science days, if you ever heard of a thing called Kepler's laws, and so these are Kepler's laws of planetary motion, and they tell you how fast something has to be moving to orbit at different distances. So it's why the planets, as they orbit the sun, they all have a different length of the year. It's not just they have different distances to travel, it's that they're moving at different speeds because of Kepler's laws. But anyway, this gas, as it's falling in, all of the gas is moving at a slightly different speed. The closer you get to the black hole, the faster you spin around the black hole. So that means that I have gas moving at one speed right next to gas moving at a slightly different speed, which means that that gas rubs against the other gas, which creates friction, which creates heat. So the closer you get to the center of this whirlpool of death, the hotter it is. So that gas glows very, very brightly. And
we'll call this, right, pre-event horizon.
That's right. Pre-event horizon. So all of this gas is glowing extremely, extremely brightly, and that's what powers an active galactic nuclei. There's a supermassive black hole with what's called an accretion disk. That's this whirlpool around it. There's an accretion disk of gas that's really, really hot. And so that hot gas gives off light, and so we see that hot gas. So ironically, the darkest things in the universe create some of the brightest things in the universe. A quasar is just a type of active galactic nuclei. We think that all galaxies go through an active phase. And in fact, our own galaxy at some point in the past went through an active phase, we think. It ends the active phase when there's no more gas down near the black hole to get gobbled up. Once it's cleaned out all of that gas, it's just a happy supermassive black hole with no active accretion disk around it. So, when we collide with Andromeda, if enough stars are tidally disrupted, those stars can fall into create that accretion disk and light up again. So it's possible that we'll create a quasar for a while.
Oh, that's cool. I mean, I kind of, again, a misconception that I had, I thought that it was almost like a burp. Like with so much junk has been shoved into this black hole that it actually emits back out. But, you know.
Oh, no. Once it crosses the event horizon, you're pretty
it's nothing. You're right. Yeah. That
now,
was one of those things that I always had trouble like grasping. I'm like, well, the one says that once it's in there, it's gone.
Yeah. Now, the exception to that, and the reason I say it's pretty much gone, is there is this weird stuff called Hawking radiation. Black holes slowly leak out energy, but that's beyond the scope of today's podcast.
Yeah, we're gonna have to do another one just for that. Okay. So
welcome to ScienceCast.
Oh man. All right, so we've gone over the death of the universe. That's cool.
Well, no, we've gone over the death of our star and
universe.
The death of the galaxy. We haven't even touched the death of the universe yet.
The death of the universe. Let's leave that one for ScienceCast.
Yeah, okay.
I did bring up Comet Izon. I was just wondering, did you get a chance to see that fall apart and destroy itself because it flew too close to the sun?
I did not actually see any direct observations. I saw a lot of the things everyone else did. You know, we have several satellites in orbit around the sun that are observing it that got some pretty good looks. But you know, it was up really, really early in the morning, and I'm not really a morning person. So I didn't see it. If it actually brightened after it went around the sun, I was going to make some efforts to go see it, but I didn't watch it myself, but instead it broke apart.
Yeah, it just gone. And
yeah, like Icarus, it strayed a little too close to the sun.
Yeah, just a little bit. And when you're completely made of ice and vapor, the sun destroys that.
It's rough. Very, very rough.
Okay, the Northern Lights.
Sure, yeah, absolutely. Love to talk to Northern Lights.
I think those are fairly interesting, and I don't think a lot of people quite understand exactly how they relate to the sun itself and how we get them, more or less.
Okay, so to set the stage for the Northern Lights, first of all, I've actually had some really good experiences with the Northern Lights. Again, I grew up in northern Indiana and Michigan, and so we've had some pretty good storms that I've seen. A lot of people have never seen one.
And I'm in northern PA. They say they can get this far down south, but I've never seen one myself.
Oh, they definitely can. Back in, I want to say it was 2003, there was a pretty spectacular one that was seen as far south as, I think, Georgia. Don't quote me on that, but I have some great pictures from that one. I'll actually tell a story about that one in just a minute. But first, let's talk about what the Northern Lights are conceptually. So, first of all, you need to know that the Earth has a magnetic field around it. And the actual origin of that magnetic field, it comes from the molten iron interior of the Earth. Let's not talk too much about that right now, but just know that the spinning molten iron core is what creates the magnetic field. So there's this big magnetic shield around Earth, and that's great because if it weren't, we would all die. Because again, space wants us dead. So the sun is constantly pumping off both light as well as this thing called the solar wind. And the solar wind is this collection of charged particles that get ripped off the sun constantly. The sun's actually losing a phenomenal amount of mass compared to our own experience. It's a pittance compared to the sun size. But it's constantly streaming off these charged particles. It's just kind of go out into the cosmos. And they're going out in all directions. It's moving isotropically is the fancy way of saying that. So it's moving out in all directions. So some of those are coming straight at Earth. And so those charged particles, when they reach Earth, they get deflected by our magnetic field rather than colliding with us. Some of those will get funneled along the magnetic field lines and slam into our atmosphere either at the North Pole or the South Pole because they follow the magnetic field lines. If you think of the Earth as a big bar magnet. When those particles collide with the atmosphere, that's what creates the Northern Lights, is these charged particles interacting with the upper atmosphere. So they're beautiful, beautiful light shows.
Do they only happen in the north?
Or
is that only because of the current tilt of our planet?
Yeah, well, they happen on both sides.
Okay.
There are the Aurora Australis, which are seen from Australia and Antarctica. So those are the southern lights. It's just that almost no one lives down there. If you really want to see it, being down in Antarctica is the place to be, and there's only like a couple of dozen people there at any given time. But the northern lights are much easier to see because there's a lot more population in the north of the globe than in the south.
Yeah, there's just more land mass.
Yeah, absolutely.
As you go north.
Yeah, we've got all of Canada and Russia and Alaska. They're all
Scandinavia. Let's not forget Scandinavia.
They've got great vantage point for seeing the Northern Lights. So they're more famous, the Northern Lights, and besides Santa. So 'tis the season.
Santa.
So occasionally, we'll hear about predictions of the Northern Lights, and they're kind of always going on at sort of a low level, sometimes not even visible. But anytime there is a big solar storm where you have a bunch of eruptions off of the sun, big sunspots, big solar flares, solar prominences, you get all these particles that spew out. Extra particles come out in the solar wind at that point. And so when we have that extra chunk of stuff coming, that's what makes the Northern Lights bright. And so if you get a really good solar storm pumping out huge amounts of solar wind, that's when we get the really good Northern Lights. Now the downside is those same charged particles don't always play well with satellites or with power grids. So if we get enough of them coming at high enough energy, they'll actually induce a current in the power grid, and they can overload transformers and cause huge power outages. So you gotta watch out for that, so the sun is trying to kill us that way. But it does make very, very pretty lights when it happens. Now, dial back to 2003. I was in graduate school in Michigan, and I was trying to see some Northern Lights because they'd always fascinated me as well, and I hadn't seen any really good ones. And there was a prediction on there's a website called spaceweather.com, and Spaceweather will tell you when they think the Northern Lights are going to be good. And so there was a prediction that it was supposed to be a really good night for Northern Lights. So the wife and I hopped in a car, and we drove kind of north of the city to someplace nice and dark. And I got out my camera and my tripod, and I was going to take some pictures of the Northern Lights, and I saw absolutely absolutely nothing. And so I put my camera on a long exposure, like 30 seconds or a minute, and I looked at the picture and I was like, well, maybe the horizon is glowing a little bit green. I guess that's kind of cool. And then I turned my camera around and I pointed it back towards the city, and there was the terrible orange haze of the city. And so I've got one picture that I pointed kind of in between the two, and you can see the green haze on the right of the actual northern lights, and the orange haze on the left of light pollution, which is a whole other topic, but it pains me.
It ruins everything. Just from where I live, being as close as we are to Pittsburgh, all I can see is the major stars. If I go to Somerset, which is an hour away, but it's up in the mountains, I can see satellites.
Right.
But it's just the city just destroys everything.
So, we were, it was kind of underwhelming, and so we decided, let's go home. And so we get back in the car, and we're driving back to the city, and my wife's looking out the window, and she says, I could almost hallucinate that maybe I'm seeing a little bit of something, even with the city lights. I think maybe I'm seeing some kind of reddish haze there. That's kind of weird. So we get back to the house, and at the time I was living kind of near downtown, but there was a little city park near the house. And so we got home, and we went out into the little city park, and we're like, we're actually like near all the city lights, and I swear to God, I am actually seeing like green sheets in the sky that are changing second by second and minute by minute. We're seeing northern lights like right here in the middle of the city. And so we're like, well, let's see if we can get someplace just a little bit darker. We won't like drive an hour or something. So we drive over to the observatory on campus, which unfortunately is too close to campus and there's a lot of light pollution there, but at least there aren't lights in the parking lot. All right. So we drive over there, and it was the most amazing auroral display I have ever seen. I was seeing aurora well past the zenith, well past directly overhead. So I was seeing aurora in the southern sky, and I have this beautiful, beautiful picture of my camera pointed at the observatory dome with the constellation of Orion in the background, and the northern lights are in the constellation of Orion, which from this vantage point, Orion was down in like the southeast. So I was looking southeast and still seeing aurora. The aurora were so bright, I have a picture of them reflected off of a puddle in the parking lot. It was incredible.
I do think I remember that happening, but I think we had horrible sky conditions for us here to see it. So,
that's kind of the 1-2 punch that people run into here. They're unpredictable as far as when the northern lights are actually going to be good. We can say the conditions are favorable, but they still might suck. And then you've got to contest with light pollution, and then you've got to contest with weather. So it might be cloudy, and you might be stuck in a city.
Yeah, my biggest issue being here in Pittsburgh is the jet stream likes to sit above us.
Oh, yeah.
So we get clouds. I think we only have like something like 30 fully sunny days a year. So like my window to see stuff like that is so small. It's really a shame.
On the subject of light pollution, I do want to mention that the vast majority of people listening to this podcast have never seen a truly dark sky. And I can say that without even having met the people listening, because most people have never seen a truly dark sky, because we all live near cities. Mm-hmm. Back in the late 90s, there was an earthquake out in California that knocked out a power grid. And when it did, 911 was inundated with phone calls of people who were seeing UFOs. They weren't UFOs. People were seeing stars and the Milky Way and the planets for the first time in their lives.
Yeah, they're really seeing them going. And the first time I got to see the satellites flying above my head, like when I was down in Somerset, and like really watching them shoot, shoot, shoot. I mean, it looks like we're getting bombarded with comets and everything else. Things are flying everywhere. And if you're not prepared to see that, it's really weird.
Yeah, it is. It is. And, there are a few stars and constellations that are nice and bright and most people can pick out. You can go, oh yeah, that's the Big Dipper, which isn't technically a constellation. It's an asterism. That is Orion. You can pick out a couple of them. But if you go to a truly dark location, there are so many stars, it takes you a while to actually find the constellations in among the other stars.
Yeah, it's really cool. So I don't know if you know this, Cluze, but I actually was requested to have you on.
Really?
Yes, a listener of mine said, you got to get Cluze on. And he makes a small request of you, which you don't have to do. I told him more likely you're not going to get to hear it, because we have no language barriers on this. And
okay, this is true, yes.
And he says, just once I want to hear him flip out and just swear at the top of his lungs. So I'm like, I don't think you're going to get that, but I'll bring it up.
Yeah, you're probably not going to get that. Yeah, I don't swear much, particularly once the mic comes on, because I've been podcasting for a while now. The other thing is I do teach in my professional life. I teach some courses at the university. And so, I've got kind of modes that I flip into. And when I come onto a mic, it's just like I'm teaching. You have to be careful about what you say.
You do?
So yeah, you're not going to hear, me swearing up a storm. I do swear from time to time. Here's actually a good example of when I swear from time to time. So just the other day, my wife and I went skiing, and it was my first time skiing ever.
You're still alive.
I am still alive. Yes. I had a really good time. I had never skied downhill before. I'd done cross country, but I'd never done downhill before. I only fell 3 times. They were all late in the day. Early in the day, I did just fine, but late in the day, I fell once when trying to get my skis off, which is a very common thing to do. I just kind of fell over sideways. And then, I fell once towards dusk because, I was wearing goggles because I had contacts in and they dry my eyes out a lot. And so I was wearing goggles, but it was getting dark enough that I couldn't actually see the terrain anymore. And so I fell twice going down the hill before I'm like, you know what? I gotta just take the goggles off, forget the eyes. It'll be fine. So I only fell 3 times, but, when I woke up the next day, because I'd never skied before, there are a lot of muscles that you use when skiing that you don't normally use that way. In particular, like to use the tow rope to get back up the hill, because one of the hills has a tow rope, one has the standard ski lift that you sit on. So that thing wants to jerk your arms out of your sockets every time you try and grab it. And using the poles to get around when you're not going down. Going down is easy. Gravity will just take care of you. One way or another, you're getting down the hill.
Yes, Sonny Bono.
Yeah, too soon maybe. But when I was at the top of the hill trying to just get around on level terrain, you're kind of pushing yourself around with the ski poles, and that's again a motion that you don't normally use with your arms. And so I woke up the next morning and my arms and shoulders were just killing me. And I will admit, I swore when getting out of bed because that really hurt.
Yes, that's a hell of a workout, a lot more than most people would realize. Cross-country skiing especially will just beat the tar out of you. I mean, your butt, it just gets so sore, it's unreal. Your arms, you can't move them for 2 days. It's a good time.
Oh, absolutely. And I also recognize that this is an incredible first world problem, right? I was slightly sore after skiing. Yeah.
Yes. Yeah. First world. So one last subject to bring up before I put this thing to bed. I will give a backstory and you can explain what's going to happen. We have a moon. Our moon was created roughly, the popular belief is that we were collided and by something large, and a lot of the earth spewed out into space, collected into a ball because of our gravitational pull and, what have you, and started running around us. Now, if you look back 1,000 years, the moon was a lot closer to us than it is now. When are we going to lose our moon, dude?
Okay, yes. So, you're pretty well spot on. This is a thing known as the impact theory and is the most likely scenario for how our moon was formed. Because our moon is just too big for the Earth to capture it properly. We're too small to have a moon this size. But if you look at the composition of the moon, its composition is very similar to the upper crust of the Earth, not the core, but the outer part of the Earth. So we believe that we were hit by something, a bunch of stuff got blown off the outer parts of the Earth, reformed into the moon. Ta-da, we have a moon. But you're absolutely right. It is moving away from us. Now, here's the thing. The moon is orbiting the Earth, and the Earth is spinning, but the Earth spins faster than the moon orbits. Now, the moon does spin as well, so don't let anybody lie to you that way. A lot of people don't think it does because the same face always faces us, but that's how you know that it's spinning. It's spinning at the exact correct rate to have the same face always facing us as it orbits. So it's kind of a weird thing to think about, but it's just pick up an orange and move it around on your table and you'll see what I mean. Anyway. So the reason one face always faces us is a thing known as tidal locking. And that tidal locking is the same tide as comes from the tides, the raising and the lowering of the tides, which, by the way, if I could just digress here, they may or may not have been a TV personality who made some rather bold claims about what we do and do know about the tides, do and don't know about the tides. And he may have said things like, the tides go in and the tides go out. Science can't explain that. No, actually we can. We know exactly what causes the tides. It's the moon. And so, the moon causes the tides as it orbits. It's essentially making the water slosh around. Let's not get into that right now. But that is one example of the pull of the moon having a physical effect on the Earth. There are other effects that are happening. As the Earth is spinning faster than the moon orbits, it's trying to change the speed the moon is orbiting at. And so it's slowly going to change the speed the moon orbits at. But because we're spinning faster than it rotates, we're actually speeding it up in its orbit, which actually boosts it to a slightly higher orbit or moves it away from the Earth, but that's neither here nor there. But at the same time, as we're pulling it forward in its motion, it's trying to slow our rotation down. So not only was the moon closer, but the Earth was spinning faster in the past. So our days were shorter in the past than they are now. The Earth is slowing down at the same time the moon is moving away. These two things are related. It's the exact same force that's doing it. It's this tidal interaction between the Earth and the moon. There will come a point where the moon will have moved far enough away that its period will exactly match the rotational period of the Earth because it has slowed down. And at that point, not only will the same side of the moon always face the Earth, the same side of the Earth will always face the moon. And at that point, the moon will stop moving away. They will be locked.
Okay.
And so there will come a point where if you want to see the moon, you've got to go to the correct side of the Earth to see it. So,
and that might be in the day, that might be in the night. No, we don't know yet, correct?
There will be moon tourism if you want. Now, here's the downside. There's a number that keeps coming up of when bad things are going to happen. You want to guess roughly when this is going to happen?
4 billion years ago? About 4 billion years now.
About 4 billion years from now, give or take. Ballpark is when it's going to happen. So,
that's our number, folks.
Yes, you probably don't have to worry about it, but it is happening. One interesting side effect of this, if you think about the geometry of it real quick. Eclipses?
Mm-hmm.
So we have total eclipses, and we also have a thing called an annular eclipse, because the orbit of the moon around the Earth isn't perfectly circular. It's a little bit elongated. So sometimes the moon is a little bit closer, and sometimes it's a little bit further away. So if the moon is a little bit further away, it doesn't quite block out the complete sun, and there's a little like ring of the sun you can see around the moon, and that's an annular eclipse. It's an annulus, if you will, so a ring. There will come a time when we can't get total eclipses anymore because the moon is too far away. So we live at an interesting time in human history, or in Earth's history, that we get both annular and total solar eclipses now. In the past, we only got total, and in the future, we'll only get annular. Now that's actual full eclipses, not partial eclipses, and let's not bother with that. But
yeah, anyway. I remember when I was a kid, this is probably one of the things that actually got me into science as a child. I might have been 9 years old, and we actually had perfect weather conditions here, which is not very often, as I've already said. And I got to see a full lunar eclipse.
Okay.
And, young kid, that's one of those things that I can look back on that, and I can think to, the days when science was not what it is today, and how people would think, oh my God, the gods are killing us.
Oh, absolutely. Yeah.
The moon is gone.
When you didn't have TVs and smartphones and the internet to look at, your entertainment was the sky. And if you were watching the moon from night to night, you're like, oh, hey, the moon looks good tonight. The moon looks good tonight. And then the next night you're, oh, it's a nice full moon. Why is the moon getting dark? Why is the moon gone? Yeah, it was disturbing stuff. But,
yeah, and it's gone when you see one of those. It's not like it's, there's a shadow on it or something. No, it disappears. You can't see it.
Yeah.
It's really cool. Well, that's all the time we're going to have from the Watchtower today. Thank you again, Cluze, for coming back on.
Oh, it's been a pleasure. There's a whole bunch of stuff that I started to touch on that we never even talked about me going to Chile or Australia to work on these telescopes. I got tons of stories about that stuff.
I know. We can definitely, do this again sometime. I enjoyed it immensely. Folks, if you wanted to get a hold of me, you can get a hold of me at Gonksuo on Twitter and on MTGO. Also, I do this other podcast called the Pit Imps Podcast every week. You can find it over on MTGcast. Also, if you wanted to send me a larger question/comment, you can send that to me at pitimppodcast@gmail.com. Cluze, if people wanted to get a hold of you one more time, how would they do it?
Yeah, so you can find me on Monday Night Magic or on Card Advantage, both on the MTGcast network. If you want to hit me up on Twitter, I am at LaCluyze. I'm always happy to answer rules questions or science questions or, well, just about anything. Feel free to hit me up. If you do need something longer form, that's a good point. You can reach me on the Card Advantage email, which is mtgcardadvantage@gmail.com, because just Card Advantage was taken. Although not on Twitter. We're at Card Advantage on Twitter, which was kind of cool. So there you go. And of course, if you want to see me in person, Durham, you can always come to Atomic Empire in Durham, North Carolina. It is a great shop. You should check it out. I'm going to be at GP Sacramento in January, so if anybody's out on the West Coast and wants to say hi, I'll be at GP Sacramento.
He'll be the guy in the bow tie.
Actually, no, I don't wear a bow tie when I judge. It is not part of the official uniform. Now and then I do. If I'm the head judge for an event, I will sometimes pull out the bow tie, but normally it's not.
You should wrap it around your wrist. No one will notice. Well, thanks again for coming on, Cluze.
It was my pleasure.
Yeah, I loved it. Until the next time, guys, I guess keep looking to the stars.
That's right. Keep looking up.